Hello. Today I'm going to show you the video for this week's lab number 1, to observe the motion of an object moving at constant velocity in the case of Newton's second law. Newton's second law states that the final velocity is equal to the initial velocity plus the net force over the mass of the system times the change in time, as I've marked right here, and sometimes it's also written as the force equals the mass times the acceleration. The interesting part here, though, for this assignment is that in this case, with a constant velocity on an object, Newton's second law will be slightly different, as you will see now when I plug it in. So the final velocity equals the initial velocity, but as the force is 0, the whole right side is 0 as well. So now we only have the final velocity equals the initial velocity. For this experiment, I started at a time of 0 and at a position of 0. And to calculate my velocity, I used the time of 0.033 seconds and a position of 0.014 meters to give me a velocity of 0.0424 meters per second. In the next part, I recorded a skull moving on at constant velocity from my reference frame and put the video in the tracker software provided for this lab. As you will now see, I've plotted the coordinates for my skull and let it move from left to right so that you could observe it moving along the positive axis. I've also used the calibration tool to get the size of my skull, which was about 6.5 centimeters. I then plotted several points along the axis for my skull at several frames to get concise data. Each frame lasted about 0.2 seconds, and I had in total 60 frames. In the next part, I took the data I got from Tracker and put it into a Python program that was also provided with this lab. In Python, I was able to put in all the data necessary to create a program that would run and create a module for my experiment. Python was quite easy to manage. Here I then used the Python and ran the module to create the graph I mentioned. Here you could see the ball moving in a positive x direction to the right, and then I also created a graph for the velocity. The velocity of the system, as I mentioned, is constant as observed by the straight graph. I then also took the data from Tracker and Python and put it into I used Google document spreadsheets, where then could create two different charts. The first was the data observed from Tracker, and the second was from the graph itself. And as you can see by the one on the right is much steeper and slightly different from the one on the left, but that's probably due to human error, as nothing is perfect in measuring. The human error stemmed from measuring the skull at different points. I then concluded to the final part of the project, which was the answer to two questions posed by the lab, which were to see if anything would change if I changed the direction of the axis. Nothing would really change other than that I would have a negative constant velocity now, and since the axis in tracker would be flipped. The second part was not quite as easy as the first, and I would say that it's impossible to really gather enough information from what I've provided to see how many pushes and pulls could be added together to give a net force of 0 in the case I observed here. For the final part of this video, I would like to again show the video I made, just to give another shot of it, and I hope that you enjoyed it and see how Newton's law worked.